Looks like we're
Thank you,
awesome.
Nick.
Thank you.
Awesome, awesome. So nice to meet you all. For everyone that don't know me, my name is Gilberto Cocchi, and I work in Google Chrome in a team that handles technical Chrome partnership. I was working in web performance and co-web vitals many years. So the result of my teamwork is usually the case studies that you may notice on web.dev or helping like Chrome guidance in terms of identifying bugs and feature requests, so on. Here, I'm here to talk, briefly about some updates about BFCache. I know that all of you know what BFCache is, but I hope I will be able to bring like maybe a different point of view, like maybe food for thought for further iteration on, efforts to work together in order to improve user experience by this web pattern overall more in the future. So first, I want to talk about like briefly about how to think about navigations. I think this group discussed a lot about navigation types and different degrees of opinions about how to measure like navigations. In Chrome, on our end, we exposed like a version of that in the Chrome user experience report, which we call navigation types. And to some developers, this was useful in the context of understanding that not all back-forward navigations are equal. There are like back-forward navigations when the browser has already need to download everything again, running JavaScript again, and whatever. Or there are the so-called navigation when the developers and the user get to benefit of the special back-forward navigation as resort quickly as back-forward cache. So in Crackspace, it's possible to measure for eligible origins this kind of opportunity, and I think it's useful for developers, maybe also the ones which are not technically skilled, enough to understand this topic, which tend to be still a niche, in my opinion, for some developers, even the ones passionate about web performance, because it can help, like especially with business stakeholders, understanding to what extent maybe they should care more about unlocking this potential. So in this example, what you see is that like for this particular domain, 44.8% of navigation types in Cracks seems to be going forward seems to be go through back forward, and only a small fraction, actually 0% in this case, go to back forward cache. That's what I mean an opportunity. Try to transform as much as possible this traffic into back forward cache, because going to 100% is not realistic for many reasons that you already know. But putting the premises of opportunity is important. Taking a little big step back on the developer, I wanted to kind of discuss like why developers should care about BFCache. We know that BFCache is a way to improve performance as measured by different performance metrics, core vitals metrics, or whatever metrics you want to you're actually measuring. It's a way to improve user experience, especially for pages high on back-forward navigation, or however you want to call it. But there are also some interesting implications from a business point of view. If you think about like a news site or a site that usually have ads, I think they have like a stronger incentive to get the most out of BFCache, because if a user get to return to the page by BFCache instead of running entirely and downloading the page and running the third-party script and eventually load the ad, they usually get more money out of it of their funky ads. So it's not all developers, take this in consideration, but there are like important business indicators which usually improve when developers deal with BFCache appropriately. And similarly for other type of sites, like you think about an e-commerce website or classifieds page where, especially for listing pages or home pages, in my opinion, notice that these kind of pages tend to be more composed by back-forward navigations compared to others. Okay, so I think it's, if you think about the developers, the motivation are multiple and not only one, and the motivations depends by what kind of site vertical you're talking to. But with motivation also comes some challenges. From my experience, developers have an hard time understanding what's preventing their page load to be eligible for BFCache, which doesn't mean it will go through BFCache, of course. That is another first challenge to go through, which creates pain on developers' point of view. The second one is understanding like, okay, if I identify like the so-called BFCache blocking reasons or not restored reasons, there are like degrees of names around this. So how can I tell which reason is supported on one browser compared to another one, which is an interesting challenge. And I think some developers have an hard time getting through this. The third challenge is understanding the actionability of a selected BFCache blocking reason. I mean, can the developer do something about it? Or maybe not. And that is also an interesting aspect, which I will be happy to give some examples for food for thought. And the fourth aspect is that imagine, developer get to enable BFCache. Do they actually realize what are the consequences of enable BFCache? I mean, it's we mentioned before, like it's usually great for the business or the code writers or user experience point of view. But what's going on with the other KPIs and things running on the website which may not take in consideration BFCache? For example, I know that many analytics providers don't trigger page views on a page resort on BFCache. They usually, some of them rely on the developer to handle by themselves. So imagine a site really high on back-forward navigation. They immediately turn on BFCache and say like, oh my God, do I have like a page view drop? Maybe not. Maybe you just got like BFCache to not, or you get like more BFCache traffic going through, and you don't actually like a site traffic drop, whatever. So there are also implications about ads and whatever in the context of what to do with specific web technology patterns on BFCache. And there's not always like a unique guidelines. So my understanding from many third parties is that they delegate to the developer to select. You enable BFCache, you get BFCache working for a browser, you handle it on your own. So now I wanted to, kind of go through, and I will get to the updates later, like just kind of a brief example about how I imagine like a developer go through like understanding the opportunity of BFCache. I already mentioned before, measure opportunity, whatever is available, encapsulate this data, but there are many RAM providers that implement these or similar degrees of kind of opportunity management, which I believe is really, really useful for developers. Because if they don't get to measure this opportunity, how do they realize they need to take any action? The second aspect is that, like, imagine like a developer identify, like, okay, back-forward cache is not working on my website, but what is blocking it? And that's why, that's where being able from the browser point of view and or from RAM analytics or other instrumentation by benefiting of, like, for example, the not resolved reasons property of the API, having the possibility to kind of give the developer like the reason or reasons for a page load to be ineligible for BFCache is extremely important. In Chrome, we have like different degrees of implementation that you're already aware. In Chrome DevTools, we had like a specific BFCache audit, which emulates like going back for, it goes to like a fake page of, I think it's a Chrome About page, and then go backwards, sorry. And reports like, hey, I wanted to try, to trigger BFCache, I wasn't able to make it work, and it exposed like the reasons in a way which, usually developers have a good time understanding what's wrong with it. What you see here is a representation of what we can measure from HTTP archive. As you know, HTTP archive run on Chrome. So in my analysis, it was extremely useful to unnest the occurrence of multiple BFCache reasons, which happens multiple combination, not alone, as you see here. The reality is much more complex than that. In order to understand like what kind of web traffic, what kind of web framework or CMS or web server or third-party presence seems to be blocked more or less by BFCache. So, and here you see like, a number expressing millions of origins according to the HTTP archive main dataset, which was helpful in my analysis to understand like, what are the top, opportunities. This is great because it's publicly shareable and it helps also to measure improvements or regressions in time. So, as I mentioned before, like what we internally we call like reason strings, blocking reason strings, not resolved reason strings, not restored reason strings, I believe are used really important. But in order to make them really helpful for the developers, I think it's good to take a step forward and understand, the actionability as I was mentioning before. So in my opinion, the developer should then be in the position to understand, like, okay, I have like a selected BFCache blocking reason. Can do something about it. I mean, for some cases, it's possible. I define them like, BFCache blocking reasons which are fixable by the developer. So either they're using an API in the wrong way, maybe they're not handling, page height correctly, or things like that. And but there are also kind of blocking reasons which are not actionable by developer in any way. So there are like, web patterns which we don't always, from a Chrome point of view, incentivize. Like, for example, using unload event handler. I think Fergal and Deepak folks talked a lot about that. But there are also some APIs, like, for example, shared worker, that if you use it on Chrome desktop, you cannot make it compatible with BFCache currently. So either you remove all the logic that you needed, to rely on this API, or otherwise you need to take for granted that no matter how much back-forward traffic you have, all the traffic will be BFCache completely ineligible. So I think that exposing this data helps not only developers, but maybe also browser vendors to kind of highlight and maybe discover like some opportunities for increased BFCache hit rate at scale. And I wanted to share like some examples, which I was able to identify thanks to the analysis that I was mentioned before by using HTTP archives. But before going through that, I also wanted to mention some about some of the biggest blocking patterns that we observed, again, from the Chrome public data on HTTP archive. I think that Fergal, maybe in the Deepak sessions, and also Barry Pollard mentioned multiple times, we definitely appreciated that the usage of cache control, no store on the web is pretty pervasive. I mean, it's I checked, like HTTP archive in the last 2 years, and it's always kind of like 21% of origins are using CCNS or cache control no store. And this simple cache control header value is completely preventing, used to be completely preventing BFCache on Chrome. So we realized, the opportunity is big. We tried, to put some effort, and we had like, a partial support for BFCache in Chrome this year, which was great, but unfortunately, for many reasons, for sensitive data, whatever, it had like a limited impact on the number of origins. So I still believe, like cache control is something that it will be. There will be like some good value to sensibilize developers about rethinking whether they use it. Because from my conversations with developers or also CMS owners on others, it is like, there is like sometimes like an overuse of this header also when it's not necessary. So I don't want to mention like technology by names, but there are like, specific CMS or e-commerce platforms which have like zero CSN usage, and others which have like 90% origins using CSNS, delivering the same kind of value, the same kind of functionality, same kind of login card or whatever, or if you're talking about e-commerce, whatever. So I think that was peculiar, and by digging more, identified that, for example, sites using Nginx on Apache tend to be really dominated by this CSNS usage, where others may not, or like SaaS versions may completely not use CSNS. We had a recent quick win on this, like the VP of Eng of Duda CMS in Tel Aviv actually recently realized that they were really focusing on performance, but they didn't notice until recently that CSNS was used on 98% of their origins. And they realized that, after looking carefully, they didn't need it for the majority of the cases. So 60,000 origins out of that dataset, according to HTTP archive, removed CSNS. And overall, according to HTTP archive, combined with Crux data, improved CLS pass rate by 2%. So the wins are there. I think it's a matter about education or better education to developers about caching headers, value best practices, and also like rethinking about some of the models, especially like some defaults in some frameworks, because I noticed that some e-commerce of CMS platform may tend to have like the defaults which always use like the most aggressive caching header values, no matter if all of the values are needed or not. And this is an example of Duda CMS origin, which started to get BFCache to work, again, showing the CracksVis data. And you can see it's maybe the graphs are not completely aligned, but when the brown line below is started to get more than started to increase from 0, which is back forward cache traffic to start to flow, CLS immediately started to collapse, to improve. I mean, we noticed that for some particular type of pages, CLS impact tend to be bigger, but the positive impact by enabling BFCache is also present on LCP and INP. And another common, culprit, which I'm sure you discussed a lot in these previous meeting iterations, is about unload event handler. So in terms of unload event handler, my understanding is that it's still present, still kicking. Most of them usage is coming from third-party scripts or providers, either analytics or ads. But there are also some nuances. For example, old version of jQuery prefer to use unload event handler when it's embedded within a cross-origin iframe. So I had worked with developers that, for example, blocked unload event handler by permission policies because jQuery wanted to use unload event handler, but it was really an old version of jQuery, not the new version. So there might be like unload event handler calls which are happening, which are not doing anything sometimes, or maybe like logics for old or legacy browsers versions. So there is definitely an opportunity there. And I noticed like there is kind of an hard time of slow action from developers and third parties to remove this. I think you already know about the current situation on Safari. What I can call is what I can talk for is for Chrome. BFCache eligibility for unload event handler is already ignored for Chrome Mobile, and we have here that Barry posted a great article about it, which we're planning to deprecate the unload event handler for the BFCache eligibility on Chrome desktop by with a 1-year timeline. So if everything goes well, Q1, Q2 next year should no longer be an issue. But there are still developers that either sometimes even call like the same logic both to unload and page hide. Is it really good? I don't know. Okay, and the fourth part that I wanted to mention, which is I was really surprised, is about WebSocket. So I find out about WebSocket implication about BFCache again by digging in HTTP archive, and it was fascinating. So I digged on the majority of WebSocket implementation usage by third parties or first-party scripts, and I still wasn't able to find one which is doing the right thing to make the WebSocket API usage BFCache compatible. We're talking about in Chrome around 600,000 origins. Impact, it's sizable, especially because these are kind of a lot of origins which are on the high end of enough spectrum. And in terms of usage, the majority is about third parties, which I categorize as chat widgets, customer supports, AI chatbots, which, as you know, are emerging thanks to this AI hype. And many of them, they block BFCache even when they are not even touched by the developer. So the fact that you just load the chat widget library on most of the e-commerce website when they have any, it's sufficient to prevent BFCache eligibility at all, at 100%, even if users don't interact at all on the chat widget. So the majority of WebSocket implementation are like this. Yeah, let's trigger WebSocket. Yeah, I'm fine. But in reality, what we would like to get them to do or advise is doing something similar to this. So yes, I mean, initialize WebSocket on PageLoad or whatever, whenever you want, but please, when page hide triggers, be a good citizen of the web and close your WebSocket connection within page hide. And the second aspect is even more important. So on page show, event handler trigger, and in the case of event.persisted, which is the case when the page is resolved from BFCache, they should restart the WebSocket connection. Otherwise, I mean, user will get to a really fancy fast page, but the WebSocket connection will not work. So that's the desired use case. Good question. Yeah, no, I reach out to Socket.io by GitHub with a suggestion. If I will happy to send the link. If anyone like want to send some +1, I will appreciate that. So, but currently, my understanding is that Socket.io is suggesting developers to use before unload and not page hide, and as an optional. So my hope is that they will improve the guidance to improve their library usage. Currently, they're also delegating to the developers to do the right thing, and I don't have perfect data, but I think majority of them are not doing it yet. Okay, in the interest of time, I'll go quick, otherwise I don't want to take the whole meeting. So I also, before I mentioned about using this data from HTTP archive, about finding also quick wins on the browser side. And looking at BFCache blocking strings by technology, by third parties, helped a lot finding quick wins in Chrome during Q1. So between Chrome 133 and 135, for example, we identified that simply reading the WebHR or WebHID property was preventing BFCache on Chrome. Or for example, calling Bluetooth get availability method was preventing BFCache because Bluetooth is not supported. So whatever you do with Bluetooth, it was preventing BFCache. Similar for sensor, and Web 10. And what we realized after, again, cross-referencing data from HTTP archive with strict usage is that some systems like bot detection systems for legitimate purposes were doing on top of the logic, also reading some of these properties. I guess because try to detect, whether a navigation is coming from a real human or not, which is illegitimate. The downside is that any website using some of these bot detection system had BFCache completely disabled on Chrome. So the good news is that we managed to fix majority of these cases. So there were bot detection system. So there were sites where developers were not using WebHID or WebHR or Bluetooth data availability or sensor Web 10, but the bot detection system was. So it was preventing BFCache eligibility. So, and that's the other aspect I wanted to mention about HTTP archive. The cool thing is that it lets you measure also success as expressed in number of origins affected by a single BFCache blocking reason. So when we got this fix in Chrome, I had to wait the April dataset, and I was able to measure success. Yes, way less origins with this BFCache blocking reason appealing. So I think that maybe this approach may be similar with to other browser vendors as well, but I'm curious for your thoughts as well. I also took a try and looking at BFCache and RAM archive. I'm not a super expert about RAM archive, but I definitely realize that there are limitations. I'm not looking at the whole web. We're looking at I think it's a portion of a sampled part of a size on Akamai, MPulse, and CDM. Please, Nick Chatman, correct me if I'm wrong. But I actually tried to look at the BFCache hit rate by months by browser vendors. It was fascinating because, for example, with changes that we had in Chrome, which I mentioned before, actually propagated to other Chromium-based browsers, which was, in my opinion, positive. So this is of course, this is not like a perfect benchmark for any browser. But for me, the interesting bit about looking at this data is looking at the delta, not the BFCache hit number, because of course it's biased by many reasons. But it was an interesting exercise, and I'm keeping to have a look. For example, in Chrome WebView, for example, BFCache is disabled currently. So if you look at the RAM archive Chrome WebView, you see BFCache hit rate 0. But on Safari is super high, for example. So I think it's interesting. I'm happy to share the query if you're curious, or if you're also not new to RAM archive. It's really easy. Great question. What did Safari? I have no idea. I was also wondering. So I'm not an expert about BFCache blocking reason on Safari. I would love to know more. So if you have, if like, here or in the future, if WebKit Falls will ever watch this recording, I would love to know. But it may be something happening on Safari, or maybe some sites on Akamai, Akamai dataset and RAM archive did something which will increase BFCache hit rate on Safari, which is also possible. So I think there might be a combination of both. So it's not obvious to give like a reason to this data. Correlation is not always causation, but if we know something that happened, for example, I knew what happened in Chrome, I was able to give, for example, maybe a reason to why Edge Mobile improved the most, or like, for example, Chrome Mobile and not Chrome Mobile iOS because it's WebKit. For example, for Chrome Desktop, when unloaded maintainer will be fully deprecated, I expect things to, I don't know, bump a lot when Fergal will finish the ramp up. So in interest of time, I also want to discuss about the not restored reason property. I know that Fergal talked already during TPAC 2022, at least, if I'm not mistaken. But yeah, what I was talking about, what you see on HTTP, what I'll show presented before in HTTP archive, is what is actually present in Chrome DevTools. But the not restored reason property allows to report that. So allows developers or RAM vendors to report that, considering like privacy implications, which are great to have, for RAM 9%. So in order to show you like the differences, this is the difference. So on the top, you see like, an output of a not restored reason property for a given website. This is great because you have like information about the main document and or the same origin or cross origin iframes blocking reason, which some limitation because friendly iframes we in Chrome we report the reasons. For cross origin iframes we don't report the reason, but we tell you like must. So we say like must means there is some cross origin iframe that is blocking BFCache for some reason, but you don't get the reasons. Okay, so that's the gist of what is implemented currently in Chrome, which is different from what you get from Chrome DevTools that you see in the screenshot below, because of course it's kind of, being as a local environment from a developer is much more specific. When possible, is pointing, to either the main document or the different friendly iframes or cross-origin iframes to say like, hey, these iframes, maybe it's as whatever, are using unload event handler. That's why it's unload event handler exists in subframe blocking reason. Which should help developer to think about what should I do? Should I block it? Maybe. So that's about it. So as a takeaway, to summarize, I think that developers have recognize the value of BFCache, but it's a complex topic. It's in my opinion, it's helpful to provide developers insights, whatever it is, to help them understand if a BFCache is not triggering, why it's not, and whether it's actually something that they can do something about it, or they should reconsider the APIs, the usage, or maybe they should go through their friendly browser vendor backlist, maybe open a feature request to ask gently to support it. So I think reporting reasons is helpful for many reasons, both for developers, RAM vendors, and browser vendors overall. And also there are like largely big opportunities, especially in WebSocket and CCNS. Unfortunately, WebSocket in particular is largely misused, and CCNS, in my opinion, is also overused. I mean, there are legitimate purposes, but remember that HTTP archive is browsing home pages. Do we really need home pages to have CCNS all the time? In my opinion, maybe not, or sometimes maybe it's not strictly necessary. So, and what RAM archive is suggesting, considering the limitation of a dataset, is that the opportunity is still large and is present across multiple browser and platforms. Oh, sorry for the too many acronyms. With CCNS, I meant cache control loss store. I'm happy to share the slides, by the way, so they're full of useful links. And everything that I discussed here is definitely public. Okay, I did it in almost 30 minutes, yes.
Yeah, let me just stop the recording and we can discuss.